Welcome to Introductory Chemistry with Dr. H. This is a video about Lewis structures. I'm going to talk about what Lewis structures are and when we can use them. Then I'm going to talk about the NAB method for drawing a Lewis structure given a molecular formula. And then we'll do a couple of examples, one involving a neutral molecule and another involving a polyatomic ion. So what are Lewis structures? Lewis structures are a way to represent the molecular structure with all of the atoms in that structure fulfilling its octet, so having an electron configuration around each atom that resembles the noble gas, that stable noble gas configuration. And importantly, we use Lewis structures on the representative elements, so that's kind of the periodic table excluding the transition metals and the F-block metals. Molecules containing atoms from the representative elements, right, those are ones that we can use most effectively with the Lewis structure model. Okay. So within a Lewis structure, things are represented in this way. We have the symbols for each element that's involved, so like nitrogen and hydrogen, they are represented. Any electrons that are in the valence of those atoms that are not involved in bonding, we call them non-bonding electrons, or if it's a pair, we call it a lone pair of electrons. Sometimes electrons in the valence are unpaired, meaning there's an odd number of electrons, and those would just appear as a little dot. When two atoms are bound within a molecule, we show this as a line, so that's representing a covalent bond. And every covalent bond has 2 electrons within it, so each little line represents 2 electrons. When we have sort of 2 parallel lines, that means there are 4 electrons. That's a double covalent bond. One last thing about drawing a Lewis structure, or how we represent things with Lewis structures. If we have a cation or an anion, at this stage, what we're going to do is we're going to draw a square bracket around the cation or the anion and put the total charge of the entire molecule on the outside in the upper right. So this molecule, right, is this polyatomic ion is sulfate, and we know that sulfate has a -2 charge, so we've indicated it up there. Later on, we're going to talk about how to identify where that charge is on individual atoms, but for right now, let's just use the square brackets. Let's talk about this NAB method for how to derive a Lewis structure given a molecular formula. So the NAB stands for needed, the number of electrons needed to fill the valence of all atoms. So how many electrons need to be added to the existing valence of the element to get to the noble gas configuration. We're just going to sum it up for all the atoms in the molecule. Then we're going to talk about the available electrons, the number of electrons that come in on each atom in its valence. So now we're just adding up the valence electrons in each atom. If we have ions, so for example, if we have a negative charge on the species, that means we have 1 more electron than came in with the valence. So we would add 1 electron for every negative charge. Similarly, we're going to subtract 1 electron for each positive charge. That means we have 1 fewer electron than is coming in with the valence electrons. So that's just a little caveat about the electrons we have available to make bonds within the molecule. And then finally, if we want to know how many bonds have to exist in the Lewis structure, we're going to take the needed electrons minus the available ones, divided by 2, because you need 2 electrons to make a bond, and that's going to tell us the number of electrons that are, or the number of bonds that are going to exist in your Lewis structure. On the previous slide, we had a Lewis structure of ammonia, so let's just see how that analysis would work with one where we already know the answer, and then we'll do a couple where we go from scratch. So when we look at ammonia, it has 1 nitrogen atom. In order for nitrogen, the atom nitrogen, to reach its octet, it needs a total of 8 electrons, so it's going to fill its octet. Hydrogen, on the other hand, hydrogen is a tiny, tiny atom, and it actually doesn't have room for a full octet. Hydrogen is happy with a duet of electrons. So whenever you have a hydrogen, you're going to need 2 electrons, and we have 3 of them, so 3 times 2 is 6, plus 8 is 14 electrons are needed to fulfill the octet of all elements except hydrogen and the duet of all of the hydrogens in the molecule. Now let's figure out how many electrons we have available, so we're working on the A part of the NAB method. When we think about nitrogen, in its valence, nitrogen has 5 electrons, so those would be like the 2s2 electrons and the 2p electrons that are there in nitrogen, so that's a total of 5 electrons in the valence shell. And each hydrogen atom comes in with 1 electron in its valence, right? The 1s1 electron, so we've got 3 of those. So the electrons that are currently available just in the valence to make bonds are 8 electrons. So if we want to find out how many bonds we need in that molecule, we would take 14 minus 8 and divide by 2. So that would give us 6 divided by 2 equals 3. So we know we're going to have 3 bonds in this molecule that we're about to draw. When you're starting to draw a Lewis structure, what you need to do is you need to arrange the atoms that are involved in the molecule with the least electronegative element in the center, at least for the simple molecules we're going to start with. So, for example, nitrogen is going to end up in the center. Nitrogen has to be in the center because hydrogen can only make one bond. Oops, I jumped ahead. So I'm going to reverse this. I know we already know the structure, but But initially what you would do is you would just lay out all the atoms. And it actually doesn't matter where you lay out the atoms. Typically we sort of put them at right angles to each other. We know that we need 3 bonds such that every atom can satisfy either its octet or its duet. And so the first thing you do is you connect all the atoms that are in the molecule with a single bond and then see if you have any left over. In this case, we don't have any atoms left over. So we've made 3 bonds. We've accounted for 6 electrons so far in the molecule. And we know that we have 8 electrons available in the molecule. So 6 of them are already gone. So in order to complete the octet of nitrogen, we put a lone pair of electrons there. Now we kind of do an inspection to make sure everything looks good. Every hydrogen has a duet of electrons, meaning it's sharing this electron pair with the nitrogen, so a duet is what the hydrogen wants. This electron pair is shared with the nitrogen and the hydrogen, so that duet of electrons completes this duet for that hydrogen, and likewise that hydrogen has a duet. Now what we're going to do is count all the electrons on the nitrogen to make sure it has 8 electrons around it, so it's achieved the stable noble gas configuration. It's got these 2, 4, 6, 8 electrons because it's sharing those electrons in covalent bonds. So what you'll notice is this bonding arrangement with 1 lone pair of electrons on nitrogen satisfies either the octet or duet of all of the atoms in the molecule. All right, let's do another couple of examples just to see how it works when we don't know initially what the Lewis structure is. So this molecule, SOCl2, thionyl chloride, is our example. So let's think about how many electrons are needed. So for sulfur we need 8, for oxygen we need 8, and for each of the chlorines we need 8. There are no hydrogen here. So we need 4 times 8 electrons to complete the duet of, or the octet of electrons on all elements. So that's 32 electrons are needed in this system to make sure everything has an octet. Now let's talk about how many electrons are available on the elements coming in. Sulfur is just below oxygen on the periodic table, so it has 6 electrons that come in its valence. Oxygen has 6 electrons on its valence. And each of those 2 chlorines that are in the 7th group of the periodic table have 7 electrons, so a total of 14. Right? So we have 12 plus 14 equals 26 electrons that are available. Okay, so now what we're going to do is we're going to figure out how many bonds need to exist in this molecule. So we're going to take the needed electrons, 32, minus the available electrons, 36, and we're going to divide that by 2. So 32 minus 26 is 3, or over 2 is 3. So now what we're going to do is we're going to arrange the atoms that are involved with the atom with the lowest electronegativity in the center. That would be sulfur. Sulfur has the lowest electronegativity. And then we're going to place the oxygen and the chlorines around it. The locations don't matter in a Lewis structure, and usually we put them at right angles. And then we're going to know that we've got 3 bonds involved in this Lewis structure. So now we've consumed 6 of the available 26 electrons, and now we're going to place the rest of the electrons in such a way that hopefully we can complete the octet of all the other atoms. And so I'm just going to start counting up. So I've got 6 total represented. There's 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and 26. So now that I've got all the electrons placed, I'm just going to check to make sure everything has an octet of electrons. This chlorine has 1, 2, 3, 4, 5, 6, 7, 8, because there are 2 in that bond. Chlorine looks good. This chlorine looks just the same, 3 lone pairs plus a bond. That's good. Sulfur, as it turns out, has a lone pair plus 3 bonds, so that's 8 electrons, so good octet there. And this oxygen also has an octet of electrons. It has 3 lone pairs and 1 bond. So we can see that all of the atoms in this Lewis structure have an octet, and so that's a good Lewis structure for thionyl chloride. There are no charges here, so we don't have to draw a square bracket or anything like that. This is just the best Lewis structure we can draw for this molecule. Okay, let's do an example of a polyatomic ion so we can see how to deal with ions. This is carbonate. I picked carbonate as the example. So we have 1 carbon that needs 8 electrons to complete its valence to make it a noble gas, and we similarly need 8 electrons for each of 3 oxygens. So again, we need a total of 32 electrons. So I'll write that here. So this is really 4 times 8, which is 32 electrons. 8 electrons for carbon and 8 electrons for each of the oxygens. Now let's talk about how many electrons that we have available. So carbon comes in with 4 electrons in its valence. Each oxygen comes in with 6 electrons, so that's 3 times 6 electrons. And now we have to remember that we have 2 additional electrons. So there are more electrons coming in than coming in the valence of those atoms, and we have 2 additional ones. So we have 2 times, I will say 2 times 1 coming in as those negative charges. So we've got 18, 22, 24. So there are 24 electrons total. All right, and so now we're going to figure out the number of bonding. So we're going to have the needed electrons minus the available electrons divided by 2. So the difference there is 8 divided by 2 is 4. So we know there are 4 bonds going to be that need to be formed in this molecule in order to complete the octet of all the atoms that are in this polyatomic ion. So now to construct the Lewis structure, we're going to start with carbon in the center, and then we're going to just place the oxygen atoms around it. We know that we need a total of 4 bonds. We're going to start by drawing 1 bond to each oxygen. And we know that we need at least 1 more bond because we need 4 bonds. So I'm just going to go ahead and draw 1 additional bond right there. I just like symmetry, so I put it right there in the middle to the middle oxygen. I've now accounted for 8 of those electrons, and I know I've got 24 total. So I'm just going to start adding electrons around. So this is going to be 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And now I'm going to stop because I've used up all my electrons, and I'm going to check to make sure that I've established a structure that has an octet of electrons around every atom. So let's take a quick look. This carbon has 4 bonds around it, 2 single bonds, each containing 2 electrons, so that's 4, and 1 double bond. That double bond alone contains 4 electrons, so carbon has an octet satisfied. It's made 4 bonds, and it's got an octet. This oxygen here has 3 lone pairs, a total of 6 electrons, plus 2 in that bond, so that gives that oxygen an octet. This oxygen has 3 lone pairs, 6 electrons, plus 2 electrons in that bond, so that oxygen has an octet, and it's satisfied. This oxygen at the top has 4 electrons as non-bonding electrons, and an additional 4 in 2 bonds to that central carbon, so there are also 8 electrons in the valence of that oxygen. So now we know that each atom has an octet of electrons. We also know that this is an ion, and it has a -2 charge. 2 of those electrons came from the -2 charge, so we've got to make sure to remember to put that whole molecule into a bracket, that polyatomic ion into a bracket, and add the -2 charge outside of the bracket. So this was a short video about Lewis structures, what they are, when we can use them, and then how to draw them with a neutral molecule and also with a polyatomic ion. So I hope you found it useful.